All right, so today we're going to talk about other sequences. Um, Other sequences mean that they are sequences that don't fall into the arithmetic or the geometric pattern. So there's still a pattern there. You can still find the next term, and you can, in fact, still write a rule for it. It's just going to be lots of out of the box thinking. So don't get discouraged. Just keep trying. Try to find the next term. Try to really think about the patterns and try to take some of the things that I'm telling you today, really like to make a plan. So we are going to have infinite sequences and finite sequences. You've kind of seen this already in geometric. So an infinite sequence just continues on forever, whereas a finite sequence has a limited number of terms. That's going to come more when we play into adding sequences together or adding them in a series. So here we're just finding the first four terms of the sequence. So if you look at these rules right here, both of these rules are not arithmetic, they're not geometric. This is not a linear function. It's also not an exponential function. So it's just one of those other patterns. So just kind of keeping in mind, refreshing our memory that the way you find the first term is you just plug in 1. So I'm going to get 2. The way that I find the second term is I just plug in 2. The way that I find the third term is by plugging in 3. And the way that you find the fourth term is by plugging in 4. So basically what's going to happen is we're going to be moving backwards. I'm going to give you this sequence of numbers to a 2680. And then I'm going to say, hey, write the rule for that. And you're going to have to come up with that. Okay, might not be as complicated, but that's ultimately what's happening today is we're going to start with a sequence that doesn't have the regular pattern, and then we're going to turn it into this other rule. Okay, so same idea over here, a sub 1, we're going to plug in 1. Sometimes you have to plug in that n in 2 different places. That's the purpose of this example. A sub 2, we're going to have to plug 2 in here, and for that other n. A sub 3, plug in 3 squared, minus 2 times 3, and then plug in 4. So 4 squared minus 2 times 4. So again, this is going to be the pattern of numbers that I give you, and then you're going to have to turn it into that rule. Okay, so this right here is just refreshing your memory that, hey, we're going to be finding different patterns. The way that you find the terms is by plugging numbers in. All right, so let's just take a look at what another sequence looks like. So here's a pattern right here, 2, 5, 10, 17, 26. Go ahead and pause the video. Think for a minute or two, whatever you need. Try to find the next term. See if you can figure out what the pattern is. All right, so you've paused the video. You're coming back here, and you're thinking, yeah, I got the pattern. I can see what it is. Did you come up with that we added 3, and then we added 5, and then we added 7, and then we added 9. So the next one, the next in our pattern would be to add 11. So the next term in our sequence would just be 37. So that's just identifying. This is not an arithmetic because we're not adding the same number each time. 37, there it is. All right, do the same thing for this one. Pause the video. See if you can come up with what the pattern is on your own. That's probably one of the toughest things to do is just figuring out what that pattern is. If you can figure out what the next term is, you probably got the pattern. So you've gone ahead, you've figured out what that pattern was, you've figured out that that next term is 13. How did we get that next term of 13? What we did was you add the previous 2 terms. So maybe write yourself a note. Add previous 2 terms. Okay, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. So these are the kinds of things that we're going to be looking at. Now I want you to pay close attention to this right here. And I want you to write down that when you are adding like plus 3 plus 5 plus 7 or plus 2 plus 4 plus 6, what happens is that you're probably going to end up with some sort of squared exponent. So I've kind of created that space for us here. We're going to write a rule for the nth term of the sequence, writing ourselves a note that says when you add plus 2 plus 4 plus 6 or plus 3 plus 5 plus 7, something like that where you're like skipping 2, that you need to think about some sort of squared exponent. So there's usually some sort of x squared happening in your problem. Other things that you should be thinking of are perfect cubes and perfect squares. And then don't forget what we know. Don't forget regular arithmetic and geometric. So sometimes we might just sneak one in there on you. Okay, so we're going to try to write a rule for this sequence right here. So we got to try to figure out what that pattern is, okay? We just did that. We're just kind of like warming up on that. We just did that pattern, right? 2, 5, 10, 17, 26. We recognized what that pattern was. It's the same thing. So we can see that we're adding, we'll just write this down again, plus 3, plus 5, plus 7. So this right here is telling us that we need to be on the lookout for some sort of square. So sometimes I think it helps us if we write out that a sub 1 equals 2, and a sub 2 equals 5, and a sub 3 equals 10, and a sub 4 equals 17. And sometimes it's helpful to look and compare the number to the actual term, the term number to the actual term. Sometimes it's helpful to think about that. Okay, so we're thinking about perfect squares. We're thinking about the number, the term, like the n value, and the actual term, how they're comparing. So I want you, again, pause the video, think about it. This is the hardest part. You really got to think outside the box a little bit. It's going to be trial and error. You're going to be plugging things in. Don't just sit here and wait for me to give you the answer and be like, oh, yeah, I got it. Okay, so you paused it, you're coming back now, and you're thinking about what that pattern is. So what your pattern is, what your rule is going to be, is a sub n equals n squared plus 1. Okay, so where did that come from? Geez, so that n squared, remember? We said there's probably going to be some sort of squared because of that pattern. So if you look at this, we added 1, then we added 3, then we added 7. So, whoa, that didn't really give us a pattern. But if I take this n and I square it, 1 squared is 1 plus 1 more, boom, there it is. If I take 2 and I square it, I get 4 plus 1 more is 5. So as I think about those perfect squares even, these are all one up from the list of perfect squares. The list of perfect squares is going to be 1, 4, 9, 16, 25. So you can kind of see that they're all just one up from the perfect square. All right, that's my rule. That means I can ask you for any term at any point. All right, I know that was a little bit tough. That's okay. We're going to do another one. Practice makes perfect. So as I look here, we're trying to figure out what that pattern is. Okay, we don't have any sort of plus 1, plus 3, plus 5. We don't have that perfect square looking. Something else to keep in mind are those perfect cubes. Sometimes, again, I think it helps if you write out that A1 is negative 1, A2 is negative 8, A3 is negative 27, and A4 is negative 64. You're trying to figure out, well, how am I going to get this 1 to be a negative 1? How am I going to get this 2 to be a negative 8? How am I going to get this 3 to be a negative 27? How is this 4 going to become a negative 64? And you know what? They all have to happen in the exact same way. It has to follow the same pattern, the same rule. So pause the video, think, see what you can come up with. All right, so now you're coming back and you're realizing, hey, I got it. I'm taking that n and I'm cubing it and I'm making it negative. So some sort of variation of this, you know, negative 1 times n cubed. That would be fine also. Be a little bit careful when you're typing it in Buzz. We got a lot of things programmed in there, but we probably don't have them all. Okay, so you see these are your perfect cubes numbers, right? Just like we kind of recognize the perfect squares, perfect cubes are numbers to think about also. Going up 1 or down 1, or up or 2 or down 2, or sometimes even just looking at the list. So these are all my perfect cubes made negative. All right, so practice makes perfect. Like I said, let's see if we can find what the pattern is here. Go ahead and pause the video. Find the next term. Think about what the pattern is. So you're coming now back after you pause the video. You're seeing that we've got this pattern. We've got that plus 2, plus 4, plus 6, plus 8. So in our mind, so that next term is 20. We got to be thinking that there's something happening with the squares. So as I think that a sub 1 is 0, and a sub 2 is 2, and a sub 3 is 6, and a sub 4 is 12. I got to think, how am I going to turn a 1 into a 0, and a 2 into a 2, and a 3 into a 6, and a 4 into a 12, all by doing the exact same thing? Keep in mind, we're trying to find some sort of squared happening in here, okay? So think about, well, what are my perfect squares? 1, 4, 9, 16. So to get from 1 to 0, I subtracted 1. To get from 4 to 2, I subtracted 2. To get from 9 to 6, I subtracted 3. To get from 16 to 12, I subtracted 4. Do you see how we subtracted that n number? So our rule is a sub n equals n squared minus n. Okay? Obviously, there's another, you could have had n times n minus 1. That would have been okay also. Those are equivalent. You're going to get the same thing. So I just caution you, as you're thinking about these, really try to make sure that you're plugging in, the first 4 or 5, whatever you have there, it has to work for all of them. It can't just work for one of them. All right, so this last one here is pretty tough. Go ahead and pause the video, try to figure out just what the pattern is. So now you're coming back, and hopefully you're realizing that the next term in the sequence is negative 12. Have you figured out what the pattern is? Have you figured out that you're adding to each time and the signs are changing? So this is a little bit different. We have to, make sure we're taking care of that too, and we have to make sure we're taking care of that sign change. So there's a little bit, it's almost like two things that are happening. If I just had 2, 4, 6, 8, 10, what would my rule be? That's kind of simple, right? If I just had 2, 4, 6, 8, 10, I didn't have to worry about the signs changing. My rule would be 2n. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So there, that takes care of the numbers. Well, now I have to think about how I'm going to change the signs. So every other number is going from positive to negative. I can't just multiply by negative 1 because then it becomes negative 2n. That's not going to work. So think. Pause the video. Really think about this. Think about using an exponent. Okay? I don't just want to give it to you, but think about using an exponent. So now you've thought a little bit, you're coming back here. So to change the signs, to change from positive and negative, if you think about negatives and with exponents, when you have an even exponent, the negative becomes a positive. When you have an odd exponent, the negative stays a negative. So if I have this negative 1 and I put it to the n power, think about that for a second. So if I plugged in 1, okay, that's going to give me my 2. Now 1 there, that's going to give me a negative. I need a positive 2. So I need my exponent. When I plug in 1, I need my exponent to be even. When I plug in 2 for my second term, I need my exponent to be odd because I need to end up with that negative. So I could simply change this to an n plus 1 or an n minus 1 even would be fine. So there is that. So to change signs, make yourself this note. You're going to need a negative 1 to an n, a negative 1 to an n plus 1, or a negative 1 to an n minus 1. And it just depends. You're going to have to just play with the formula a little bit. It just depends on which one you want to be positive and which one you want to be negative. All right, almost done here. Check out the next video.